Hi, my name is Becky, and I am a senior data scientist at Netflix. I have been at Netflix for a little over 3 years now, and prior to that, I did a PhD. Oh dear. I did a PhD in physics at Caltech, so local gal here, and I work on our content data science team, largely doing machine learning to do predictive models for demand for titles. Today I'll be talking about how our culture interacts with data science in particular. Netflix has a really wonderful, unique culture. A little bit about how our data engineering teams really form the backbone of what I do. A little bit about sort of the philosophy of how you approach data science as a team, not just as an individual contributor. That's the Hamburger Stands versus Butlers. I promise I will explain that. And then a little bit about the data science ecosystems that Netflix ends up using for all of this. So to start with, what I talk about when I talk about data science at Netflix. To start with, I thought I would give some context for how we think at Netflix, not just about data science, but everything. And so to that end, there is no way for me to discuss data science at Netflix without discussing culture at Netflix. It informs everything about the way we interact not only with each other, but also with our stakeholders. And so expect me to mention these things often. They inform a lot of how we approach what we do at Netflix. So freedom and responsibility, context, not control, and then we have these core values. We have a really great memo that's available on our jobs website if people are interested about that. And so to sort of highlight what this looks like in practice for me, I'm going to start with our culture of freedom and responsibility. And so the idea here is that at Netflix, we are given this really unprecedented amount of freedom. We're free to choose how we work, what we work on, the hours that we set for ourselves, how we educate ourselves about this process. And that's really special because, and it comes with the corresponding responsibility. And so like one example of that for me is that I, for example, am free to use any programming language I might like at Netflix. I happen to use mostly Python with a smattering of R. Some folks only use R, but we have a couple of like diehard C++ and MATLAB holdouts and all kinds of things. And so you have that freedom. If that's what you work best in, then you're free to do that. But then your responsibility there is to make sure that whatever you do integrates with the rest of our tech stack, is understandable to everyone else on your team, and is usable by everyone else on your team. So if you choose to write something, for example, in C++ when everyone else is writing in Python, then it's really on you to, for example, create an API or a microservice so that everyone else can access that without having to become a junior C++ programmer in order to understand what it is you're doing. Similarly, in terms of choice of projects, my relationship with my boss is really so collaborative, right? Like, she doesn't actually say, like, here's what you're going to work on. We talk about the kinds of things I'm interested in, what kinds of things are important to us right now, and I have the freedom to say, like, oh, this thing came up from some stakeholder. I'd really like to work on that and, like, you know, get through this in like 2 weeks. And she says, yeah, go for it. If you think that's what has highest impact, you're free to do that. And it's my responsibility and it's my judgment to choose things that aren't just trips down rabbit holes, right? Satisfying my own curiosity is not enough. You have to have impact. And so that's what freedom and responsibility means in terms of how we think about data science. The other thing that we talk a lot about is context, not control. So similarly to the fact that, like, my boss and I, she doesn't control what I do, right? She sets context for me. She says, here's what I see as the biggest areas of need for the business. And giving me that context helps me understand what it is I need to work on. So she doesn't have to micromanage me. She doesn't have to say, you're going to do this and this and this. And then in terms of how I interact with other people, so a really common thing that happens when you're a data scientist is that you have some stakeholder who has a way of doing things. And that way of doing things historically, since data science is this new field, although data and analytics is not, they have their way of doing things. And you may be trying to convince someone who's old school to switch to doing something new or doing something data-driven. And you cannot, and nor should you, just go in and mandate and say, like, now we're going to do it this way. I've decided this modeling approach is better. We're going to do it. No, no, no. Like, it's on me to provide the documentation, to communicate, to give them impactful, innovative results, and convince them that this is the better way to do something. If they take a look at what I've done and they say, that's too hard, I've failed. If they take a look at what I've done and say, that doesn't change, like, that's not a meaningful change for me, that's on me. And so I can't control what they do. I can only set context for, I've done this thing, here's how I think it can be helpful to you. Use it if it makes sense for your life. So now that I've talked a little bit about how culture interacts with data at Netflix, I thought it might be interesting to give you a little bit of the context of scope. So our science and analytics team is about 125 data scientists and data analysts on 5 sub-teams. And these span a lot of different areas. Most people think of Netflix, they think of recommendations, but actually we use data science all across the company. I happen to be on the content and marketing team, and so this is my disclaimer that the rest of this talk is really informed by that experience. I'm not necessarily speaking for the other areas of data science at our team. And also, like, you know, I also have the unique position of I'm one of a smaller group of data scientists who work here in Los Angeles rather than out of our main headquarters in Los Gatos. And so, to be specific here, you're getting my viewpoint today, right? This is not, I don't know how well it generalizes, but this is my experience at Netflix as compared with other friends of mine who are doing data science at other companies, at startups, so on and so forth. Just as importantly, we have a data engineering team that is about 125 engineers, also on 5 sub-teams. And note that this does not include the vast scale of engineering at Netflix, right? We have product engineering, we have cloud engineering, a lot of other kinds of things. This is just our data engineering department. And you'll notice here that most of this, not most of this, but a substantial fraction of this goes towards building out our data infrastructure. And this is really key. This is the thing that lets us do what I call data science at scale. And I'll talk a little bit more about what I mean when I say data science at scale. And so what I want you to take away from these numbers is the following. One, that data science and analytics touch every area of the company. It's not just about the recommendation algorithm, it's everywhere. Additionally, we find that everywhere across the business, people are hungry for data. It's a really data-driven culture. People want to know, is there data that can help me make this decision? Is there data that could help me do better in the future? And that's going towards that context, not control. Secondarily, you'll notice that we have mostly only applied research, and that is because we're all really focused on creating impact. And then thirdly, notice that the 2 teams are the same size. Data engineering has absolutely equal priority with data science and analytics. And actually, I would argue that in many ways, it's the thing that comes first. It's actually more important than the data science organization. And I think right now, data science is having this very zeitgeisty moment. And so I want to take this opportunity to really highlight the beautiful work of our data engineering teams. Because good data engineering is what lets data science scale. Oh, this might be a good time to mention. We are currently hiring data engineers and data scientists. So if you know anyone or if you yourself are interested, come talk to me, or we have a couple other Netflix people here afterwards. So why do I value data engineering so highly? There's a truism in data science that data science is 80% data and 20% science. And I have found this to be absolutely true. And without good data engineering as a backbone, you end up in really one of 2 cases. Because the data engineering has to happen. It has to happen even if it's the data scientist who's the one that's doing it. And so in the best case scenario, your data scientist becomes an okay data engineer. Typically, they're never going to be as good as the specialized data engineer. And then in the worst case, your data scientist is going to become an extremely overpaid data entry person. And so I'll talk a little bit more about these. The worst case scenario isn't something I observe at Netflix. It's something that I've observed watching, in particular, friends at startups who people got, I think, a little overexcited and jumped the gun on hiring a data scientist. So let's talk about the best case scenario first. So you hire your super scrappy data scientist. They come in, they pull together some data sources, they build a data set, they train some kind of model, they get some useful predictions out of it. Everyone is super happy about this. And then inevitably, they say, that is so great. Can I have this every day, or every week, or at least every quarter? And so in the best case scenario, your data scientist is going to scrape together some like unholy combination of cron jobs and probably some open source, Airflow or Luigi-like tool. Maybe they'll get it stashed on an AWS machine. Maybe it gets fed into some visualization tool like Tableau or Periscope. And And so this is great, but inevitably this is going to break. And so then your data scientist has two choices. They can either try to continue being a great ETL engineer and figure out more of this process, or just do the whole thing over by hand every time, which is time consuming. And either way, here are the things that your data scientist isn't doing. Your data scientist isn't improving on the original model. Your data scientist isn't working on new projects. And your data scientist isn't learning new things about other areas of the business where they could be providing impact or doing new things. And so this is where if you have someone who's really, really good at that earlier piece, at that data engineering piece, not only do you get better data engineering because you have someone that's very good at it, you also free your data scientist up to go do things that they are specially capable of doing as well. So an example from that I can take from my personal experience at Netflix, you can imagine that in order to predict demand for new titles, which is what I work on, we need data on titles. And so this comes from lots of places, from external license data, from our own internal viewing data. We need to get all this data, and then it needs to be organized, cleaned, understood, all of the things that are associated with this. So here's our first version of this. We have some data set that has a title name and a studio. So we're like, great, got some data, except these two things are not the same, right? And of course, anyone who works on people knows this very intimately. There's so many Matt Smiths in the world. There's probably even so many Matt Smiths born in 1972, et cetera, et cetera. And so, okay, so we're gonna make this a little more complicated. Now we're gonna have our unique keys be title name and release year. Great, so we're making progress. Second complication, there were 4 titles in 1995 released with the word Pocahontas in them, at least 3 of which are animated, right? And so you can see how this quickly becomes a really tedious data cleaning exercise, right? And so one of the beautiful things that Netflix does for us, and I have to admit, as a data scientist, I am utterly spoiled by our data engineering teams, is that they actually created a movie matching service that takes all of our data sources and matches them together based on like a sort of like a fingerprint of each movie. It matches all these data feeds. It resolves conflicts. So if you get 2 sources about the same movie, and one says it was released in 1995 and the other one said it was released in 1994, what's the right release year? You have to decide which of those data sources is actually more credible. It also handles things like alternate titles. When titles get translated from one language into another, it may not get translated the same way every time. Some titles get re-released under different names, et cetera, et cetera, et cetera. And so what they do is they make this, what I call this unified data set at the end that is really broad, really general, way more general than any one data scientist would build for themselves. But there's this lovely underlying data set now that every individual data scientist can pull for their own unique analyses. And so rather than having all of us all the time trying to do this for ourselves, they've made a solution that lets all of us go straight to the end part of it. And so it feels like you get to skip steps, which is really fun. Okay, so in the worst case scenario, someone says data is the new oil, and it's the hot new thing, and we need to hire ourselves a data scientist. And your data looks like this. There's nothing to be done here, really. There is no ETL. There is no warehouse. What happens here is that your super scrappy data scientist becomes a super scrappy data entry person. And so this, I would argue, is putting the cart before the horse. And this is really more, this is not so much a Netflix thing, this is more of a early stage thing. There's some great information just out in the world about what stage you should be at what stage of your startup in terms of having a data warehouse, what kinds of analytics you should be doing, things like this. You do need some of these base level things, and I would actually even argue that you get the vast majority of the value out of your basic like data analytics and BI. Data science for me is really like, it's the cap on the end. You need all of that good stuff at the beginning first. So Hamburger Stands versus Butlers. This is my way of comparing 2 paradigms for how you might structure the flow of demands from other areas of your company into your data science team. And note here that when I say butler, I'm not talking about like some very obsequious sort of like old school, does whatever they're told servant. I'm talking about butlers who they were managers of households, right? They had staff, they did finances, they managed in estates. I mean, these were people who were essentially CEOs almost of their own companies. And they were a second pair of hands, they were a second pair of eyes, they were second brains for their employers. And so what do these two things have in common? First of all, they're both service oriented. They don't exist for their own sake. The customer happiness matters in both of these cases. They rarely work solo, so you can work alone as a restaurant, but even taco trucks usually have at least 3 people. So you do need a team of people to get this done, and they're good at juggling demands on their time. So the hamburger stand, this is a paradigm that I think is really easy to slip into. You get requests and you fill orders. You get requests and you fill orders. Someone comes to you, you deliver back. Someone comes to you, you deliver back. And that's a good thing, but it's not really strategic. And I find that it breaks down once you start getting to a certain volume, because first of all, you're treating all your customers the same, and you don't necessarily have the context of like, I have 5 requests coming in from 5 different people. How do I know which of those is the most important thing to do, right? And so your metrics there are just about like filling orders. It also requires your customers to know exactly what they want, which is a really tricky thing. Someone may come to you and say something like, I need a model that predicts lifetime retention, right? And that is a huge ask. And what they actually mean is, I need a way to compare the effectiveness of marketing campaign A to marketing campaign B. And so understanding even what it is they're asking, or having them understand what it is they're asking becomes problematic. I would argue that what we try to do is we try to be the butler. And so the idea here is that you want to be ahead of your guests' needs. You want to be there before they even know what they want. You want to be there even before they ask. So you anticipate the needs, you anticipate what's going to happen. You have to really understand the business. You have to understand where your customer is coming from, the kinds of things they're likely to ask you to do. And so the idea here is that we're providing insights and models and predictions in a way that's smooth, it's seamless, they can access it all the time without even noticing we're there. And I'll talk a little bit more about how we do that, which is this idea of data science ecosystems. And so Netflix has hundreds of predictive models deployed across the business for the entire company. And so how do you do this at scale? And the answer is that we have this data warehouse that I've talked about with our data engineers. We also have a machine learning platform where you can essentially create and host any kind of model that you might like. And then the thing that we found that really works well for us is putting all of our models behind some kind of microservice, writing an API so that all of these internal apps throughout the company, which they may be as small as like a little Flask app that someone has just sort of like set up on their own, to something that has like a full-fledged internal dev team, they don't have to worry about whether my model is written in Python or R, whether it's serializable, whether it's anything, right? All they have to know is how to call the API. And so we do this so that, and our emphasis here is on reliability and maintainability, right? It doesn't do very well if like every third time you call the API, you get back some broken thing, or like it's not up half the time. And so part of the way that we do this really effectively is we do have really close partnerships with our data engineering and dev teams. So the same way we don't want to be hamburger stands, they don't want to be hamburger stands either. We don't want to just throw stuff over the fence to them. So part of this whole machine learning platform was them actually anticipating our needs, saying, oh, we see that the number of models being deployed across the company is growing. Rather than finding an ad hoc solution to every individual data scientist request, why don't we build out this platform? It's self-serve, they can push their own stuff up there, and now we're not gatekeepers anymore. So they're thinking about our needs, we're thinking about our customers' needs, and it grows, it grows, it grows. There's an emphasis on maintainability. We try and focus on graceful error handling. I know a lot of our ETL engineers sort of have this 4-day rule, which is like, if your ETL fails for whatever reason, transient or something like that, for 4 days in a row, your processes should all be able to recover gracefully up until that 4th day. And sort of similarly here, like, you shouldn't have to go in and like futz with it every time there's a little failure, right? Like it should handle some failure automatically to make it a really robust, nice experience for people. Lastly, just sort of what is expected of the data scientists at Netflix. It's a lot of the things I already talked about in terms of our cultural values, being good communicators, obviously having some really deep knowledge in something specific, whether it's machine learning or causal inference, and then some moderate software engineering practices, which is part of what lets us do this at scale. So we use Git. We try and strive for reproducible or documented research. For me, that typically takes the form of like a published IPython notebook where someone can go in, they can access my data, my code, my model, they can run it for themselves, they can tweak it, they can, and the lovely thing about IPython notebooks is that you can put in the explanation of like, here's why I have to do this step, here's why I chose these things, here's where I'm optimizing my hyperparameters, et cetera. It is expected that you contribute to a shared data ecosystem. And then, like I mentioned, the microservices for the ease of model access across the company. So, thank you very much. You are all released to go to lunch. I don't know if we have time for questions. All right.
Why did you choose IPython over something like Zeppelin or some of the tools that are out there? Oh, why did you choose IPython notebook versus Zeppelin or some other tools that are out there?
I guess it's Jupyter Notebook now. For me, it's the freedom and responsibility thing. I happen to like IPython. It works for me. We have a really nice service that lets us publish our IPython notebooks out to the broader community. So it was already part of our ecosystem, and it worked for me.
Thank you very much for speaking. That's great. My question is, what kind of ETL system do you use in your work? Is it SAS, is it Oracle, or is it another database?
We're Hive, basically. Yeah. And then pretty much, at least in my work, it's Python after that.
In your infrastructure, who's responsible for data QA?
It depends on the maturity of the particular project, honestly. So some stuff that is sort of blessed starts to become owned by our data engineers. If you're still in kind of like a greenfield space and you're doing some of that like early data collection yourself, that falls more on you, but that's really more like getting to that MVP. Once you've established that like this is a valuable thing, we intend to like essentially put this into production, that's when we start getting our data engineers involved to try and figure out like, okay, I did this on an ad hoc basis, how do we make this reproducible, good, all of those things. We also have a really nice internal auditing tool called Quinto that lets us just do some of these things easily. Like I said, we're spoiled.
Maybe one more question.
Thanks for a nice presentation. You mentioned about maintainability of a model, and you also mentioned that in Netflix you have hundreds of models you translate. Right?
Yep.
So my question is, when you have a kind of distribution shift of data, like when your data change, how do you manage the kind of large amount of models change at the same time?
Yeah, so our machine learning platform, it's again, we're ridiculously blessed at Netflix. So that also includes things like being able to schedule training and refreshes. And so like my model suite, for example, it refreshes nightly. And that is something that I can just set and it automates and it does that automatically.
Any more questions? I think we are good. Thank you.
All right, thanks very much.